Okay. I'm still waiting. Can you guys see from over there?
Yes.
Yeah? Oh, sorry. So, for M, this is from 1504, the actual exercise. So, it's 4 to the power of x plus 1 equals 1 over 8 root 2. Now, what's the first thing you do? I can actually just take x plus 1 down, right? Write it as a logarithmic equation. So you have, this will be x plus 1, the power, equals log to the base of 4 of 1 over 8 root 2. So in the calculator, you can just put in log on the top 1 over 8 root 2 over log of 4. Can someone tell me how much that is? Minus 7 over 4. So even though it looks very complicated, it actually ends up being a very simple number, right? A lot more neater than what it looks like here. So it's going to be x plus 1 equals minus 7 over 4. Now you just have to move the plus 1 to the other side. Minus 11 over 4. Right? So for this question, don't be intimidated by these numbers. If a question asks you like that, even though the numbers look different, you must be able to solve it. Because when those teachers make these questions, they're not going to try to trouble themselves as well. Right? It's going to end up being a neat number once you sort it out. So from challenges 1 and 2, is there anything I need to talk about?
Yes.
I said from 1 and 2, is there anything?
No.
So question 3, which one?
All of them. There's 3 questions anyway.
Okay. Can I wipe out question 4 now?
Yeah.
I didn't think I was going to have to address this question, this problem in this class. But if I identify whoever that's making weird noises, I'll give it after school straight away. Don't do it. So question 3, it says determine the value of t. Corrected to 3 decimal places. So basically in this question t is just x, right? So you have first one, it's 1,000 equals 1.8 times 10 to the power of 2t. So before you do anything, you need to first divide both sides by 1.8 because with this index, there's a coefficient to it, right? And the coefficient is 1.8, so I'll divide both sides by 1.8 first to get rid of it. So what's this? 1,000 divided by 1.8? Huh? 555 exactly? So 555.5. This is equal to 10 to the power of 2t. Right?
5.6 would be round.
No, it's alright, I'll just keep this for the time being. And then this is once again just an index equation. You just have to bring 2t down by changing it into log. Right? So 2t is equal to log 10 of 555.5. So now divide both sides by 2. T is equal to log 10 of 555.5 divided by 2. Whatever this is, that's your t. And don't forget to correct to 3 decimal places. Question B is exactly the same, right? You have to first, what's the first step you have to do for question B? Mariam's already said it, yes? You have to divide both sides by 100, right? Because that is the coefficient. Question C is slightly different. So now you have 6 times 3 to the power of t minus 1. 2t minus 1. Plus 3 equals 27. What is the first step? Divide both sides by 6. Is there anything that comes before that? Move the 3 to the same side as 27, right? Because whenever you're solving an equation, the first step you're doing, no matter what equation you're solving, is to combine loose numbers. So if you have any whole numbers or fractions that you can combine first, do that first, just to get a housekeeping out of the way, right? So you have 6 times 3 to the power 2t minus 1. If I move 3 to this side, it becomes 24. And then the next step, divide both sides by 6. And as you can see, if I do dividing by 6 on both sides, at this point, the numbers also become a lot easier to look at, right? Because on the left-hand side, you just have 3 to the power 2t minus 1, because the 6 and 6 get cancelled out. On the other side, 24 minus divided by 6, this is just a neat 4. Once you have this, yes? Because 10 is the base, it's not a coefficient.
For that one, is it the coefficient? The 3?
No, 3 is a loose number, so you combine it with 27, because it's plus 3, not times 3, right? Okay, so here you'll have log 3 of 4 equals 2t minus 1. So you solve it as normal, right? So from this point on, I believe I don't have to talk about it. Question 4, which ones do I need to do?
D.
So I'm just going to do question D, yeah? Can I wipe out question 3A?
Yeah.
So question 4D. Yeah. Who is it?
It's Mr. Prati talking to 3 girls.
Oh, okay. Okay, for this one, can I just take log on both sides straight away? Oh, sorry, can I change it into a logarithmic equation?
Yes.
How?
Log 10, 5.
Yeah, that's called taking log on both sides, right? I can't do it exactly the same way as this one because I have pronumerals on both sides. So what you need to do is take log to the base of 10, and I said it yesterday as well. At the moment, just write log 10 completely, just so you know there is a base already. So whatever you're writing here is going to be the actual resulting number. So 5 to the power of x plus 1, that's equal to log 10 of 8 to the power of x minus 1. Now I can bring the powers down, right? So x plus 1 times log 10 of 5, this is equal to x minus 1 times log 10 of 8. Then the next step is just combining everything that's like. So x plus 1, x minus 1, they're like terms, not like terms, but they're the same nature, right? There's pronumerals. So combine them, x plus 1 divided by x minus 1. This is equal to log 10 of 8 over log 10 of 5. To put into the calculator, this is just log 8 over log 5. And then you solve it normally, right? Log 8 over log 5, we write it as a decimal, that's all. Yes? Yeah.
It wasn't like x minus 1, it was like 2x equals 7.
Oh, actually, 4C is different. Has anyone done 4C?
No.
Yeah, me.
What's your answer?
0.
It is 0.
Don't worry, I'll get up from school.
Did I wipe out something important?
No, you wiped out for 3 state, I was still doing it.
Oh, sorry.
It's alright.
Okay, sorry. So can I?
It's alright.
Where can I
Rub it out, rub it out. I'll get
Are you
it.
sure?
Yeah,
Okay.
I'll
So for C, you have 3 to the power of 2x equals 7 to the power of x. So if we do it normally, we'll have to take log 10 on both sides. Right? So log 10 of 3 to the power of 2x equals log 10 of 7 to the power of x. So bring the 2x down, 2x times log 10 of 3. This is equal to x times log 10 of 7. But then, when you do the next step, you'll realize that if you take the x to this side, they get cancelled out. What does that mean? Let's try it. So if I divide both sides by x, I'll get, this is 2 equals log 10 of 7 over log 10 of 3. And if you put this into a calculator, you'll see it's obviously not equal to 2. Right? Did something go wrong? Is this equation just not valid then? What is actually happening here? When we divide both sides by x, we're already excluding a value. What value is this? 0, right? Because when we divide something by a number, we're assuming this number is not 0, because you can't divide anything by 0. So if you divided both sides by a number and you see this equation does not hold, that means x has to be 0. Yeah? So here I can say from this, I know x has to be 0. And also, if you're familiar with indices already, you'll know that if you have two bases, the bases are not the same. And they're 2x to the power of something. And with this one, 3 to the power of 2x, I can simplify it to 9 to the power of x. Right? 9 to the power of x equals 7 to the power of x. When will that ever be valid? Unless, it will never be valid unless x is equal to 0. So you have y equals 1. Right? That is the only possible case. So that will also give you x equals 0. But if you can't think of that off the bat, just do this working out and tell me, because the equation is not valid, x has to be 0. So that's homework questions. Thank you for your book. Alright. I'll give you the handout for actually Renez. Can you please give out the actual handout, and Serene, can you give out this? So make sure you get 2 things. One is the handout for today. One is the exercise. Could you please take this to the laptop and give back to Mr. Lee? Thank you. Has anyone not gotten a copy of the handout? Anyone else? Has anyone not gotten the handout? Sorry. Okay, let's start. There shouldn't be anything you're right now. Saying, stop. This is the last exercise we're doing for log. After this, we're finished. Okay? This is practical applications of logarithms. We've already talked about that many times throughout this topic. So there's earthquakes, right? With the magnitude, we use logarithms, but we never really said how it's used. There's also sound, so how you perceive sounds. There's also pH values. So you obviously use pH values in chemistry. What values are there? 1 to 14. How do we determine these values? Yeah, so if it's between 1 to 7, that's acidic. Yeah, 7 is neutral, right? So anything between 1 to 7, 7 exclusive, that's acidic. And then from 7 up until 14, that's basic. But then how do you test it? You probably use a piece of paper. Or you use a container or a solution to test it. But what's in that solution to tell you that? It is a chemical. It's a chemical. It's a chemical that actually tests how much hydrogen ions there is in that solution. So they test how many molecules there are, right? And it's not going to be a big value. It's going to be 10 to the power of negative something. So it's a very small volume. And see how here it says pH value is equal to negative log 10 of m. This m value will always be given to you. This formula, if the question wants you to do it, will also be given to you. So you don't have to worry about memorizing that. So first one, it says calculate the pH of the solutions that contain the following moles of hydrogen ions.
Why are we doing science?
I swear.
Well, because math is used in physics and science, right? So if we want to apply math, then half the time it's going to be about science. Okay. Can you sit up? So we have this formula, pH equals negative log 10 of m. And it tells me 10 to the power of negative 3. Is this, what is this? How do I use the formula? So I substitute it into m. So you have negative log 10 to the power of negative 3. Then how do you simplify this? Bring the power minus 3 to the front, and you have minus 3. So that's positive 3. So positive 3 times log 10 of 10, which is 1. This will give you that the pH value is 3, right? So this is how you calculate it. You basically just put this value into the formula, and then the pH value is right there. So can you try to calculate question B yourselves? You literally just substitute it into the formula. Yeah. First, I didn't bring my calculator. Sorry. Pardon? It's also part of this. Yeah. So this is the whole amount. So 3.6 times 10 to the power negative 5. So pH, negative log 10 of 3.6 times 10 to the power negative 5. You can actually just put this whole thing into the calculator. So you can, or maybe you can move the minus 5. No, just put it straight into the calculator. Because log 10 is just log. Right? In your calculator, you're putting minus log 3.6 times 10 to the power negative 5. Minus 4.5. But then it's minus 4.5. So it will give you positive 4.5. Right? So it's just 4.5.
Oh, I just put, I did a log over 10. Log of,
So log of whatever that is over log 10?
yeah, and I just saw
Yeah, because I already said log to the base of 10. Log to the base of 10 and log, they're the same thing, right? So if you did your way, it's just the longer way. You can just put in this straight away into the calculator. It will give you the same answer. Okay? Yes? 4.4, yeah. 4.4, 4.5.
Miss,
Yeah?
can you put negative log in the calculator?
Yeah. You can put in exactly this. So you can even add the negative sign in the front. Yes?
Why did you put a minus in front of 4.5?
That's just the formula. Oh, you mean inside brackets? Because that's the value you get, isn't it?
I got 4.5.
Yeah, because you put the negative already.
Okay. Example 2. So we're using the same formula because we're looking at the acidity of a solution, right? So negative log 10 of n. Now you're given the pH value. You just have to substitute it into the left-hand side instead of the right-hand side, right? So 9 is equal to negative log 10 of n. Now what is the first step? Can I just change it into an index already?
Yeah.
There's this negative sign. So take the negative away, divide both sides by negative 1. It will be minus 9 equals log 10 of n. Now I can change it into an index equation. Right? So m is equal to 10 to the power of negative 9. Right? So it's a very, very small value.
And we write it all.
What do you mean you write it all?
0.0000000.
Can you leave it like that?
Yeah, just leave it like that.
Oh, yeah.
Okay. Second one, can you do it yourselves?
Yes.
This is not very hard, is it? Not yet, yeah?
That was a hard exercise.
I think if now you go back to 1503, you'll be able to do it a lot better.
I don't think so.
That's good. So with this one, you can just leave your answer like this. 10 to the power of negative 2.8. Alright, can I move on?
Mister, we don't have to memorize these formulas.
No, you don't. Pardon? Who asked the question?
Me, I said it's this extension.
You mean log? Log is in...
This like.
No, it's not. It's not.
Oh.
Not yet. Huh? This is. Alright, once again, half the class are waiting. If you want to talk, maybe I can move you outside. You can sit in the corridor and talk to yourself. Okay, second one is measuring sound. So if we let the minimum sound intensity audible to the human ear to be I0, so this is going to be just something we compare the actual sound to I0, then the intensity I of any sound can be measured relative to I0. So this part you probably don't really care about. And then the relative intensity, this formula is what you do need to use. But then once again, it will be given to you in all sorts of questions. And sound is measured in decibels, so we just use dB. You don't really need to know exactly what it is, but as long as you see decibels or dB, you just need to know it's a measure of sound. So it says, first of all, calculate the relative sound intensity of a sound that is 1,000 times I0. What does that even mean? I0, we already said, it is the minimum sound that human ear can hear. So what does it mean? It's 1,000 times of I0. It's 1,000 times louder, right? So maybe my voice now is like 1,000 times louder. So S equals 10 times log 10 of I over I0. Where does this belong? This is I, right? So all you need to do is substitute it once again into the left hand side. So 1,000 times I0 over I0. And you can see that. Top and bottom, there's I0. So I can just cancel it out. Once I've cancelled it out, you'll be only left with 10 of log 10 of 1,000. Isn't this just 3? So this will actually simplify to 10 times 3, which is 30 decibels.
This?
Mm.
Why did it become 1,000 I0?
Isn't there an I0 on the bottom
Yeah,
as
but
well?
I don't know if there isn't an I0.
I is equal to this, 1,000 times I0. So you substitute this whole term for I, okay? B and C, can you quickly do it yourselves? Yes?
So how have you done 10 times 3?
Yeah.
Do you just cross out?
Yeah, log 10 of 1,000 becomes 3. So quickly do B and C yourselves, please. You just have to substitute the value. It's 1,000 I0. So I substitute is moving into the top. So on the bottom it should be I0 as well. Yeah. Yeah. Can you do B and C? Yeah. Do both B and C. You finish? It's log 10 of 1, 1. It's log 10 of 50. You too. Okay. Let's have a look. So, second one, question B is pretty similar to question A, right? You will get, I think, 17 decibels. Because you'll have 10, so 10 of log 1050. So you put log 50 into the calculator, it will give you maybe 1.7. 1.7 times 10, that's 17. Alright, question C, when I was looking through some of your working outs, I saw that many of you actually made a mistake here. With I0 divided by I0, what does it become?
One.
It becomes 1. Right? Because top and bottom are the same number. That means this whole term becomes 1. So 10 log 10 of 1. What is log 10 of 1? 0. So you just have 10 times 0, which is 0.
You know when you put in the calculator, do you put log 1 over log 10 or you don't have to put
Just log 1.
Oh, it'll give you the same answer.
Yeah.
Right?
Okay. Can I scroll down? 5 more seconds. Okay. How many times louder than the threshold of hearing is the sound of these relative intensities? So 40 decibels. This is now the S. So S is equal to 40. Your formula is S equals 10 log 10 of I0 over, I over I0. Right? So now S is equal to 40. Which means you have 40 equals 10 log 10 of I over I0. So it looks like it's going to be exactly the same, but here there's something you have to be careful about. So first step, what would it be?
Move the 10.
Move to 10, right? Divide both sides by 10 first. So this becomes 4, and this gets cancelled out. So you have 4 equals log 10 of I over I0. What do you expect your answer to be? Is it going to be just the number?
No.
It's going to be something times I0, as you saw in the previous question, right? But how do I get there? Now I have 4 equals this. First, can I change it into an index equation?
10 to the power 4.
So 10 to the power of 4 is equal to I over I0, first of all. And between I and I0, which one is the one you want? I is what you want. So I is going to be equal to, I just have to move the I0 to the other side, right? 10 to the power of 4 times I0.
Why did you? I don't understand the last step you did.
I just times both sides by I0. Because you want to find how much I is equal to. Right? I is on the top. I0 is on the bottom. So times both sides. But then, how many times, because the question is not asking me to express I as an equation of I0. It's asking me to find how many times louder. So which one is your final answer? 10 to the power 4. Right? It just wants you to say I is 10,000. So 10 to the power 4 times louder than I0. So 10 to the power 4 is your final answer. Make sense? Yeah? Do question B yourselves, please. What's 10 to the power 2.5? Can someone calculate it? 316.2. Alright, thank you. I'll just keep 316. So maybe at this point you can just say it's 316 times louder, right?
James, do we have to do the last step?
No, even here you can just say it's your final answer already. So just keep it as your final answer. Because if you rearrange the equation, you're just getting this coefficient anyways, right? It doesn't really make a difference. You're just doing 2 extra steps for nothing. Yeah? Just keep this number. Yes?
Example 3. Is it like 2 questions?
Not really.
Miss?
Yes?
This do you leave it as the index or as a whole number?
Just leave it as a whole number.
Oh, so we have to change 10 to the power of 4 as a whole number.
No, you don't. It's the same. This is just a scientific notation. It's still a number, whole number, right? Jana, can you see that? Mariam?
So we don't have to write 10 to the power of 4 equals I over I0, or do we have to write that?
You don't. As long as your answer is correct. Okay? Alright. Can I move on?
Yes.
So question 3. How many times louder than a sound of 20 decibels is a sound of 37? How would you do this question? Correct. So you find them both, and then do you subtract?
Yes.
It says how many times? Divide, right? It's not asking you for the difference. It's asking you how many times. So you need to find both and then divide. Okay? So 20. Decimals? What do you mean?
Should we round up to the first decimal?
You can just keep a whole number. Yeah? Can you tell me how much it is?
Oh, this one is
It's
5.
50.11.
No, it's 5,012.
5,012.
5,012.
And then do you divide it by each other, miss?
Yeah.
Which is going to give you
Alright. So the first number you get is 100. Second number you get is 5,012. Is it necessary to write I equals something? I equals 100 times I0 or not? No, not really. Because this just tells me 20 decibels is 100 times louder than the minimum, and 37 decibels is 5,000 something louder. Right? So how do you find how many times this is louder than that? You just have to divide the big number by the smaller number. 15.12. Or 50.12. And I guess you can just say this is approximately 50 times louder. So 50 times louder. But this does not mean whatever is 50 times louder than the minimum. It means 37 decibels is 50 times louder than 20 decibels. Right? 37, sorry. Any questions so far?
No.
Okay, let's look at the last one. So the last one is just earthquakes, magnitude. So there are 2 methods. Okay. So the first one is the most popular one, just the Richter scale. So it's just I take log 10 of whatever magnitude it is. So you have it says what's the relationship between the amplitudes of earthquakes of magnitudes 5 and 4. So A for amplitudes, right? So you can do M is equal to 5 or M is equal to 4. Can you do it yourself? In this formula, I just have to substitute M equals 5 and M equals 4 in there, right? So you have 5 equals log 10 of A. So A is equal to 10 to the power 5. And And then for a magnitude 4, 4 is equal to log 10 of A. A is equal to 10 to the power 4. So these are the two amplitudes. But it says, what's the relationship between them? Basically, is one bigger by how many times? By 10 times, right? Because you have, for magnitude 5, this is the amplitude. Second amplitude for magnitude 4. So it's basically 100,000 and 10,000. You can see that it's 10 times bigger. So it's 10 over 5. Always do the big number on the top, small number on the bottom, because it's more natural to say something's a whole number times bigger than another thing instead of something smaller, right? So 10 times bigger. Ten times more intense. And the next one, you pretty much do the same thing. What's 10 to the power 3.7? Oh, it's the same number. So 5,012. Now once again, just put the big number over small number. So 10 over 5, or 10 over 5 over 5,012. And keep the whole number. 20 times? Yeah.
Yeah, so we don't have to put it in calculator. Can we leave it 10 to power 3.7?
Yeah. And then once you have 10 to the power 3.7, do 10 to the power 5 over 10 to the power 3.7. It will give you the same answer. Okay. Can I move on? Next one. So you have, this is another method. It's not measuring amplitudes anymore, it's just measuring the energy level. So M is the magnitude, E is the energy, right? Find the amount of energy released in an earthquake of magnitude 6 on the Richter scale. Well, actually, it means just substitute it into this formula. So it's going to be log 10 of E equals 4.8 plus 1.5 times 6, right? This is 13.8. So E is equal to 10 to the power of 13.8 kilojoules. And you can just keep it like that. Because once you put in the M value, it becomes a very simple logarithmic equation, right? Yeah.
What happened to them? Oh, no.
M becomes 6, yeah? Alright, next one. Next one, how many times greater is the energy released by an earthquake of magnitude 7? So, what do? You substitute it. Yeah, so it's very simple, isn't it? So log 10 of E equals 4.8 plus 7. Sorry, 7 times 1.5. So that's 10.5, 15.3. So E is equals to 10 to the power 15.3. That's for a magnitude 7. And for magnitude 6, we already found it's 10 to the power 13.8. Right? So you just have to do big over small. So 10 to the power 15.3 over 10 to the power 13.8. Whatever this is, that's your answer.